Well, this is John Black, super chemist. We'll give it another try. Try to make some ethanoic acid, or most commonly known as acetic acid. We're going to take the ethanol, vodka, potassium permanganate, and should come out with this acetic acid and these things here. This we can filter out. So I got your molar masses here. I multiplied them by how many moles they tell me to in the equation. 3, 4, 3, 4. And it gives me these numbers here. But I don't want to go by that because that's too much. So I divided everything by 6. I divided that by 6 and I got 29. Divided that by 6 and I got that. Now for the alcohol, 29.2 milliliters is what I need. But if I have 40% alcohol or 80 proof alcohol, I need to divide by 0.4. And that tells me I need 73 milliliters of 80 proof to get that 29.2 milliliters of alcohol. The water is I just made it dilute, which was a big mistake. Now if you look at your products, you're going to get acid and a base, and that's going to react to make salt water, right? So you're going to have only 1 mole of potassium hydroxide, and the other 3 moles will react with this to have 3 moles of potassium acetate. Okay. Now over time, and not much time, this potassium hydroxide will convert to potassium carbonate, but only a half of a mole per mole of that. Okay. So I took the molar weights of these and I multiplied them by what the equation says, by 3 by 1/2. And then I divided those by 6, just like I did up here. And that will give me my theoretical yields for each one of those salts there. We'll see how it goes. Most books tell you that you should use acidified permanganate. Alright, so I got about 750 milliliters of water in here. 105.4 grams of the potassium permanganate. It's all stirred up so it's dissolved. Right above it I got a water cooled condenser. It's that good kind. Has the coils in it. Above that I have 73 milliliters of ethanol. It's just vodka though. It's not distilled or anything, so it's only 40%. 60% of it's water. That's in an equalizing funnel, and then up at the top I have it capped. Even though you shouldn't cap it, I'm not going to cap it tight. I'm just going to leave it on there real loose. Okay, I'm going to start dripping in my alcohol. As you can see, I'm just dripping it. I don't expect much to happen. I tried this with just water and a little sample, and it did oxidize it a little bit just by it sitting there over time. But this definitely will need reflux since I'm not using acid. The old manual stir. You can see it dripping in. I got my condenser on. And actually, I already smell a little bit up at the top of the condenser. I mean, I got to put my nose up there though, and I can smell some acetaldehyde. And one thing I did learn, because this is my first experiment here that I'm filming, I did learn after that
you should put your when you're adding this stuff, when you're adding the alcohol or the permanganate, you need to cool everything down. You need to put an ice bath on the pot that you're dripping the stuff into and have everything cold. That way, the acetaldehyde it just escapes. You know what I mean? It's just hard to keep control over. But if you put an ice bath on it, you know that stuff is really soluble when it's cold. So that's all it takes, really.
Alright, there were two other things that I learned, and I suggest you do other than using an ice bath when you're adding the alcohol. The other two things are to extend the condenser. You'll see here I got the same condenser I used. It's a 300 milliliter, and it's the coil type, so it's really good for refluxing. And this was my first experiment, but by the time I got to the fourth experiment, I had used this plus another 300 millimeter condenser that I think was called a Liebig, and then I had another Liebig that was 300 milliliters, but I didn't put any water through it. And so I did extend the condenser out so that none of the acetaldehyde got out. Another thing is the water, putting so much water in. You know what I mean? The more water you have in there, the more you gotta wait for it to evaporate or boil it off or whatever. So I mean, instead of 700 milliliters or whatever I put in there, maybe I should have put 5, or 4 maybe. Maybe each time I'll lower down the water to see, until it looks like it's going too fast. Keep in mind, in this reaction, our only acid is water. Okay, there is no sulfuric acid, so the acid is the water. So there's very little protons in there or whatever. Very less acidic, so it's weaker. So putting less water in is, I don't know how low you can go, but I would think that all the way down to where it is just enough for the permanganate, the potassium permanganate to be dissolved. You know what I mean? As long as it's dissolved at room temperature, I think that's good. You know what I mean? But I don't know. You might need to add 100 or 200 or 300 milliliter on top of that. But my point is since you're making a carboxylic acid and you want it to be oxidized, you know what I'm saying? I don't think having it dilute is, you want it dilute to make an aldehyde because you want the aldehyde to be able to escape before it gets the second oxidation done to it, and then it's a carboxylic acid. So you want it to be dilute. But here we're making an acid. We want the double oxidation. So making it dilute is kind of counterintuitive. I mean, counterproductive, because at the end you're going to have to get that water out of there. And you're actually making some water during your reaction, so you're adding water there too.
I'll stop the dripping for a second. Well, nothing really great happened. I'll take us downstairs and reflux it as soon as it gets that last little bit in there, and see we'll take it from there. Well, I lost the reflux footage, but I did reflux it for about an hour.
You can't see it on camera, but there is a top layer here that's clear. And, I mean, it's dirty, but that shows you that it's probably done. I refluxed it. Now I'm going to filter it out. And this is a good way to make MnO2. That's a byproduct. Oh yeah. Crystal clear. Right? So it's obviously a completed reaction. Okay, so I lost the footage of the reflux, and I lost the footage after that where I filtered it. I just stole a clip from another video. That's what you just saw a minute ago. But this is the stuff that got filtered. Keep in mind the potassium hydroxide that we make right, from this reaction. By the time we get done, and I put it on my radiator and let it evaporate most of the water off and then filter it. By that time, a lot of carbon dioxide will be dissolved in the water and react with the hydroxide to make a carbonate, potassium carbonate. So when I get done, what's in solution, most of it will be potassium carbonate, if not all of it. Should have all the hydroxide probably by then has gone through the reaction to make a carbonate. So just keep that in mind, that if you try to extract that out, that you'll end up with a carbonate. When you're done, and also when you're done filtering out the MnO2 to see if it's clear, if it has any purple, then everything needs to get thrown back into the pot and be refluxed more until that purple color is gone. The MnO2 that you already filtered out, you can either throw it back in or you can wash it off with some water and throw that water back in the pot to be refluxed along with the other stuff. Until that purple is gone when you filter it, your reaction isn't done. What I did, I made a mistake. All my samples, when I got done with the experiment, as long as it went clear, that was it. I was done. I set it aside. I didn't really cover it up that good. I just put a piece of paper over each thing, and the little bit of acetaldehyde that was made, it was in solution. It kept coming out, you know what I mean? And it wasn't bad for the first 3 reactions, but the 4th one, even the mini ones weren't that bad, But the one where I under-oxidized everything, and I took it out, and it was purple, and there was a big clump under there that didn't get reacted. That I should have put it back in and refluxed it more, all of it. I didn't. I just let it sit there, and I went on to the next experiment like an idiot. And that acetaldehyde, wow, it made a lot. But it's so soluble, and I had my contacts in, so I couldn't see close. It takes my close vision away. So I took my contacts out after I blacked out pretty much, and I could see it bubbling. It was like little tiny bubbles just floating up, man. Like if you had some pop sitting there after a while or whatever, and you looked at it, you'd see little bubbles, going to the top or whatever. But it was all acetaldehyde. And this was a couple days later, you know what I mean? So it kept coming out for like 2 days or something. So be careful about that. If you have, you under-oxidize it like that or something, be careful. It will make you sick, and it will make you black out if you get enough of it. But during the distillations, I really didn't, unless I put my nose right up to the top of the condenser, I really didn't smell anything that bad. Alright, part 2 to this video will be about the stoichiometry of not only our product, but also the MnO2. And also 3 options to get or use the main product. And the main product is the potassium acetate. But there's a byproduct of potassium carbonate in there also. The MnO2 is easy, you just filter it out. We showed that. Always remember, science is great.